Let's take a look at how to create a part with TTN in SolidWorks. First, you need to create a working interface for the part. And then in part design, there's some ability to create parts. The first is to create parts, the second is to dig holes, the third is cut diagonally, the fourth is to quickly dig holes, and the fifth and face of the guide angel. This is safe. Let's click create parts and I can find it inside. There are a lot of commonly used end types, but also some of our common pipe parts. We create one where we can input a length of the pipe. Diameter and wall thickness. This is the name of the place where the part is kept. We can also keep this part in the parts store, so you can find it directly in the parts store next time. Create. This creates a circular tube. And then let's save it. Just save it where you want it. Let's look at the second function. Dig a hole. This place is some type of digging hole. We can make this shaped holes in this round pipe. It has round holes and has this. Square hole with chamfer, oval hole, hexagonal hole. This is the diameter of the hole. This is the end surface, and the end face has left and right. I can switch it. The right end is 0 on the right end. The left end is 0 on the left end, and then this is an offset in the X direction. Enter R. This is the exact offset, and this. You can't really see the effect. This is one way through. We choose to add a hole on the side. Still add a hole on both sides. Click on the Create. This hole has been added. Let's do another one. Other parts. These are some of the dimensions of the parts. You can refer to this picture. This creates a channel steel. Dig a square hole. So you have the hole, and then you look at the tangent, and this is the plane of the tangent. This is the direction. Let's adjust it. You can choose different directions according to our different needs. This is the end face and it's the same things as what we just said over there, left or right. This is the degree, the angle of the diagonal card, and this is the distance to the root. This place, that's the distance to the root, the angle of the rotation about the x-axis. So it cuts off the hypotenuse like this. Quick to dig holes. It's all the same, square hole. The type of hole, which plane the hole is on, the size of the hole. The distance of the hole position and angle of rotation. This will quickly create a hole. Just save it. Let's see. For some functions in the toolbar, you import a part first. TTN is enabled, so it opens up on top of the toolbar. And let's see, the first one is the coordinate system. When we are importing parts or drawing parts, it has a coordinate system, and that's how we draw the parts. In other words, all the data generated by the parts are based on its changing direction, its rotation direction, its characteristic direction, and so on, sometimes. The coordinate system that we are drawing is different from the coordinate system that our software recognizes. Or sometimes our coordinate system is not so accurate. Maybe I have a plane there's a little bit of the x and y axis and not exactly on the x or y axis. In this case, we can make an adjustment to the coordinate system. So from the function of this coordinate system, make an adjustment. So let's look at this one. Operations interface, automatic coordinate system, rotating coordinate system. That's a rotation direction that you can set. Rotation left, rotation right. I can take a look. It's the difference, rotate to the left. Look at this frame, this blue frame. You turn it around again, maybe adjust it. Adjust the surface of the coordinate system. This is the change direction of the part. Now the change direction that you see here is the change direction. One click to create, and this frame is created. What else does this place do, like when we cut? The position of our cutting hand is always exact position, and then under this correct coordinate system. If the pipe is installed, it defaults to zero surface cut. Or the zero surface, the surface that you start cutting is this surface. Not very convenient for this type of C-section steel. And then we want to use this wider face to make the plane of the first cut or to make a zero face. So you can point this exact axis to this wider plane. The exact axis points to the wider face so that when it's processed, the first cut starts on the face. Its default zero surface is this white one, and also the number of degrees of rotation of its coordinate system. You can make an adjustment here, a 45-degree rotation. So this is the coordinate system for our graph. When it comes to software recognition, it's not a special one. A square coordinate system, you can use the function coordinate system adjustment to make an adjustment. Okay, so let's take a look at some of the features in the toolbar. This is to save all modification information of parts. This is the toolpath configuration, which has been described in detail before. Generates a toolpath and deletes a toolpath. This is a simulation, and there are two forms of simulation. One is a simulation of karting, and the other is simulation of code simulation. We can see some data from the code simulation interface of our program, output and see, and the production report, which I talked about before, the function of the lead. Let me do another graph. Generate knife path. This place is the lead, and we can set the lead from this place. Automatic place move delete selected leads. Delete all the leads and take a quick look. Automatically is just an auto add and then put. This is the type of lead, straight line or arc. The length and angle of the lead, we can take it. Select the outline and the lead changes to this position. This is the way the leads are moved, a little bit like the placement. The mobile. Check a box and you have two choices. The first one, if you click on any edge, you will move to the center of that edge. The middle position, you can click on this one. The location you want to add, delete. Just go straight to the outline of the lead. Delete it is gone. Delete all, it will remove all the leads from the entire encounter. Is this our handling of the lead? Let's look at the next micro connection. Micro connections, there are also several ways to add them automatically. Place, delete, and the delete all. Look at the auto add microlink. Actually, this place is connected to the microlink in the knife path setup. It's the same thing. We won't talk much about it here. These data are the same as those in the knife path settings. Some through the gap, some through the quantity, and some through the leading point. And then sort. Automatical sorting sort is that discard sequence which was in the past setup displays. I've already said that decompensation. Apply to the selected contour. Whichever contour you will select, you will add this compensation to. Apply to section. Apply to all and then clear compensation. Apply to the end face. You will apply this compensation quantity. It applies to both of these faces. Applies to all of the contours. It applies this compensation. Let me do another graph. These graphs. This knife is the amount of compensation for the weld because it has a word thickness. And then when you cut, this word thickness will have an effect when you make a split. So this compensation is going to cut away the word thickness. Let's see how it applies to all of them. So let's start with this round hole. It also applies to this compensation quantity, clear it out. I think we've talked about this in great detail before. This is a beveled knife path like this one with a very thick word. When it cuts, it's affected by the thickness of the word and this place inside of it. There's a certain amount of the interface. But if you do a 5-axis cut, it can cut out this angle completely. So let me see its normal line. Its normal line now is perpendicular. Let's switch. 5-axis path. Take a look. The angle of the normal line is the same as the angle of the slope. It's going to look like this, vertical, and it can be applied to all knife path. All of its contour paths, which will have an angle, become this 5-axis path. Compensation for the contour. Let's do another shape. Use this to generate a path. As we cut affected by the gap. The actual size we cut may have some deviation from the size we set. We can adjust the amount of compensation for this contour. Give it to cancel this error, which is contoured to compensate the operating interface. Indented. For example, if the hole is cut too big, you use indented. Then there is no compensation for its normal according to the original size of the card. And then it expands. And when it comes out, it's smaller than we want it to be, so you expanded it a little bit. Set it to a large size and see what it looks like. The following statement is valid for selected contours and for all contours. Let's look at the first one. All of its normals will now be larger than its contour. So that's called separating out the position of the normal line is the check of the actual movement of the cutting hand during the cutting process. And if you look at the indented, you can see that there's a gap in there. It's 1 mm, so it's going to be small, and this applies to all the profiles. Once you've selected it, look at one of these effects, all the contours. Including the end face is going to have this compensation. This is based on the actual processing needs. Then make a choice. This is a setting for the cutting process. Select and then outline. Set different layers corresponding to different cutting process. For example, if my requirements for this hole are not so strict, then I have the ordinary process of cutting. But if I have a hole and have high requirements for its cutting effect, I need to set a separate cutting process for this hole. So these two holes is two cuts, so you can do the position with layers that they are different colors. Select an outline. Okay, it's going to be layer 2. Large profile, medium profile, small profile. And marking this hole if it's too small. When I cut it, if it doesn't cut enough, then I can change it to marking. It will use the marking process to make a mark and then later processing. Select and confirm. Select and confirm, click on it. This selection of this place, you can choose the outline, you can also choose a certain edge. If you look at this area, after it changes the layer, its color will also change. This is visible in blue, this is visible in black, and it may not be particularly visible. But you can see the difference. Let's go to the next one. The attributes of the contour. These codes are the contour on the part. These cut processes, this is the layer of the contour we just modified. Large profile, medium profile, small profile. Do you want to cut with both axes or 5 axes? This is a process. Compensation and perforation, and so on some simple process operations. Here you can actually carry out a batches processing. We can look at it very briefly. Use this ROM code. Generate the tooth path. This is a 5-axis tooth path. A 5-axis path. Look at the outline. The outline is this code name. I change it to 4-axis knife path and then change the layer to 3 layers. This place is already a 4-axis knife path. Multi-layer editing. We can have a look at the selected contours are processed in a unified manner. You can see this surface. Well compensation. This black line sound tubing. It will have a weld, and this is where we weld at the work angle. It's adjustable, okay? This black is where the weld is. A card in the corner. Look at this surface. This was mentioned earlier in the two-path configuration, which means that my edge is a hypotenuse. If I cut the hypotenuse directly up the last part, the effect of this piece might not be good. So I'm going to add a marking to this surface. That's a marking so that when you cut it, it's guaranteed. This hypotenuse has a cut effect. It was in the knife path setup. This place in advanced knife path settings is the same. I'm going to do collision detection in a second, but I'm going to do the different graph. To generate the path, look at this line first. Now it cuts an outline. There are two. You make a knife path set up there. Slender cutting, regenerate nav path. In this case, it only has one line, the reserve of the knife path. This line is cut from here to here, and I'm going to do the reverse, so I'm going to take it. Make an adjustment in the direction of the cut. That's how it adjusts. Break the seal halter. This line may be too long and I don't want it to cut through. If you cut it all out, it might be affected by some hard hit and it might not work particularly well. And then I want to split it, so I will cut it off. So it's divided into two sections, the first and the second. This is where the interruption occurred. You can be at the center, you can be at the selection point. So here we are at the center point, which is if you just select this contour, it will calculate the end center for you by default. Make an interrupt at the center. This place, it will be in the place of your choice. I'm going to interrupt you. Use micro connections when you interrupt at the beginning or at the end. When we interrupt now, is this outline and there's no gap between the next outline. And then I want to add a macro connection between these two cities. There's a tiny connection between the two profiles. You are like this thin strip. If the wall of the tube is very thin and then it's cut very long in the middle, it's definitely going to be subjected to thermal deformation. Is going to go sideways. Open a little bit, it will be a little bit thinner in the middle, so you can put one of this little connection in the middle. And then you don't want to distort this pipe too much, because if you do it badly the first time you cut this, it will affect you. The precision of it cutting the contour of other surface. Breaking edge, this one is breaking outline, is going to be on a close contour. That's an interrupt operation, and then this one can do the separate interrupt on the edge. Look at here we have pieced the edge together. Long groove cutting. Choose a long slot. You can set its distance. How much distance do I cut? How much distance do I cut? You can set the amount. I'm going to cut this long slot a couple of times at 127. Take a word at 127 and then cut out this long slot here. I can take a look. The long groove will be cut section by section. This is long slot cutting. Chop it up. Sometimes we will do it in a different slope shape. This figure, you see it has a very thick wall, and then this pentacle, when it done, is less likely to fall off. At this point, you can add a minus to it, the one that cut it. Where the waste is, it falls off smoothly after cutting. The normal knife path is like this. And then AFT, after I choose minusing, this is a minusing point. the first point, the second point. Here you have to choose because it has thickness. You have to select it and cut outline will do, and that adds another paragraphs. When it cuts, it takes this part of the position and it cuts it up. It's easier to get it out. Merge contours. At the beginning, we just added these lines. It's a single one, and when you merge these two seahouses, it comes a silhouette. This one and this one is starts off as a separate curve contour, and then you merge it and you get a two of them make a silhouette, so it cuts through in one stroke. High sensing, I will talk about that later, and that's open section. The statistics of the cross section is really just some information on the front of this tube, cutting information. It's also about the tubing, one length of the pipe cut. What is the length of the cut, the cutting time, and so on. Punch a simple cut information of the data. We are looking at some special shape tubing. Also look at some of the previous knife path. Congratulations. Advanced knife path settings do not talk about these functions. We lead in a channel still. Import the channel still. The channel still. To generate the nav path, let's take a look at the channel still. This type of tubing, it cuts a way through the path. Advanced knife path configuration, C-shaped still this as the cut. Introduction of knife moving mode. P1 is the position where the higher sensor is locked, and the P1 is the first point reached by the cutting hand. And then you go down in the direction of E2, and then you go out, and then you go. I'm going to go over here. E1 at a certain height, and then I'm going to go over here to P2. Go to P2, which is the starting point of the cart. The starting point of the cart, starting from P2, the cart begins to emit light. And then you go further. P3 is high sensing. A position to close P4 is the end point of the cart. The words in it is actually a layer, but the current function cannot be used for the time being. We will not talk about it. Using a highly sensitive card, break the edge from the beginning of the contour. This distance is essentially the same. Where do I start applying height sensing? This is the end of the contour break edge. And then E3 right here. Where to start? This is the height sensing range setting. Automatic leading, automatic lead out. I won't talk about this step. And with the height sensing, reserved thickness. This reserved thickness, this place set, this channel still, it has a work thickness. When the cutting hand finishes cutting A4 and reach P4, it stops cutting forward. This reserved thickness is the distance calculated in terms of word thickness. If you leave 100%, it cuts to the last place. It doesn't cut anymore, it cuts to 50%. Then it cuts to the thickness of the wool, and then it cuts in 50%. Then instead of cutting, let's look at the cutting path for the current contour cutting. This place, you see this is the wool thickness. It cuts through the wool thickness and it doesn't cut any further. Let's change it to 50%. Let's try it out. This place, this is the word thickness, is going to cut 15% more in front of the word thickness. You can also set this distance. How much is the thickness of the word cut forward? This is the first edge machine path. Look at the second side. This is the cutting hand and it falls right here. Page 1. Pick 1. Then go ahead and start cutting. All the way down here. The rest is the same, and if you look at the web is the middle plate. This is going to sit on the web and start cutting, and it's going to cut through the entire web. Cut a little bit out here. And what's really important about this is that it cuts these 3 edges. It has to use this height sensor for all shapes too. Because if you don't use height sensing, you go down into this empty space at this point, you might step. But if you cut directly from the outline, this kind of special shape pipe, its external size is not so standard. It's subject to some dimensional deviation, some may cut off and some may not. It's a C-shaped pipe. Here we are. This profile after I generated a knife path. Some profiles because of drawing some reasons or other reasons. Cause it to automatically generate the tooth path. It cannot generate the tooth path. At the time, you can manually add the tooth path. You can select the outline and add the knife path separately. Then look at the manually added knife path. Its line is directly at the end. You just come down at the end and start cutting. That is to say, The add knife path doesn't have a high introduction. If it has high introduction, its cutting points are oriented a point inside the interior, and then we select the contour and add a high sensor to it. This is the high sensing set of a value. Then look at this line. Now it's changed, and its starting point is also include this contour. Go out and make a card, and it's highly responsive at a The other lines are gone, and we can look at this single line. High sensitivity. This place will change, especially pay attention to the position of the next knife point. It's going to have a change when you meet someone like this. The system doesn't automatically identify the machine contour and doesn't automatically generate the machine path. You can select it individually to give it a two-path processing. This is C-section still with right angles. Let's see. C-shape still with rounded corners. Check the knife path settings. Advanced blade. Rounded C-section still where it's a circular arc. At this point, it cuts differently than a right angle. Again, the cutting hand goes down the inside of the contour, turns on the high sensor, and the sensor goes here. And then it starts to cut, and when it gets to this point, it doesn't stop it. It rotates, and it's actually treated as the corner of the square too. Rotate and cut to the end. Rotate, cut again, and come out again. And this place, when you look at the right angle channel still, it's going to have this face on it, and this face has a web on it, and it's going to have 3 parts, and this is just one part. Let's look at the angle. Create a new angle. Create a new one and take a look at the knife path. Let's see. Cut one edge, turn it, and cut another. If you look at the diagram of it, right angle still. It has 2 sides. The first side cut this. The second side cut like this. It has 2 cuts. Let's see another one with round. Create a new interface. Create a new work interface. Rounded angle, still look at it. How do you cut it? Generate the path. Rotate the card. Rotate cutting and look at the schematic of it. There is only one cutting surface. Let's look at more complicated I-beam. I-beam is in the section card. It's kind of complicated because it involves the needle piece and the cutter is going to cut the middle piece. If not handled properly, it can easily become dangerous. Let's look at one of these cut paths. Generate knife paths first stimulate to see the cutting mode. Middle web cut, two sides cut. Take a look at the cutting diagram. Eye steel, this is cutting diagram of eye steel. It has three sides. The first face, the second side, and the third side. The way we still with three sides. The third side in particular, we handle differently. This place, we'll talk about it later. The first edge is as these parameters. The first face with channel steel is about the same, and then the second face is also. They are all similar. It's the third face. Is completely different, the main outline of this place. Cut this place after the corner ends. Start the hem in front of the corner. And then the hem of the corner length, and then the angle of the insertion and this place. Trim the radius of the two paths on the arc. So let's take a look at this path, which might be a little bit more intuitive. Let's simulate. You can see the cutting hand goes to this piece, and now the place is already hitting the cutting hand, including this rotating path. It's already hit the cutting hand, so your path you are very dangerous in the actual cutting process. So this path right here. We are going to do the process on this article. This is where the web is. Look at the location of the web. Let's turn that on first, the hem at the corner. The hem in front of the corner length. Insertion angle. (20°). Take a look at it first. Create a knife path. If you look at the normal of the place, normal of this place, this guy is changed. Is at your new value, which is this place, and this place is the hem in front of the corner that you just typed in. This is an angle of it, and then let's stimulate it again and see if it changes anything. At this point, it begins to tilt slowly, and then tilt. There's still a little bit of collision going on here, so let's see how another adjustment parameter is applied, okay? Let's take a look at the eye steel in the knife path setting. considering the radius of the two paths on the arc is now 100. If you look at what it looks like, it's an arc now is 100 and it is all cut off. And then we change it to 80. Generate. When you change it to 80, this arc is only cross this part. This percentage that you change is the percentage that it doesn't process, which means that when you go to 80, it only processes 20%. Change this place by the percentage that it processes, which is the range that it processes this arc. It can affect the position of the cutting hand to swing from side to side when cutting, so as to avoid some collisions. Of course, if we just look for collisions, it's not accurate, so we can go through the collision detection feature. Let's use collision detection to see if the knife path interferes. You click on the beginning of this place. To complete, the following is collision detection detects knife path points and interference points. This where the interference is as a percentage of all the processed contours. Let's change the direction. We can see in red where there is an interference. This is a knife path. This is an outline of the inside of the knife path. I can take a look at the side. This place is interfering. This place is also a little bit. Let's see where it interferes in this outline. The position of the end of the line interferes. You can be in this place. Make a change to it and enter the change value. The interference in this place, look at its size, rotation. The rotation of the 10 degrees. Minus 10 degrees, so it doesn't interfere. This color is going to turn green, so let's do the next card. It's the outline of the knife and see where it comes from, the first knife. This place may not be visible now. And then if we test it again, it doesn't interfere because we just change this point out here and these two overlap. So you test it and it doesn't interfere, but there's still interference. That's still interference. Look at the rotation of the chunk. Change it to degree of the rotation of the chunk like this and it won't interfere. So this all interference, this clears up. Look at it. Oh, this place, the last one is still line. Finally, there is still interference in the place of one knife. Let's change the degree to small one. Just cut it right here. The contour is completely unintrusive. Do you want to see it? That will do. Let's go to the next one, disk outline. It should also be at the end of the line, the same as there, and I don't know the degree of this place. It can't be negative, also to be positive, because it's going in different directions. There's no lower part, the first card also not test, and then the second card. The second card needs to be overturned 50 degrees here. I'm going to change it to 12 degrees, which is getting bigger and bigger, and it's going to check this. There's no collision at 12 degrees. Slowly cut, and there's bump here. 45 degrees make it 30 degrees. It doesn't call it, and then discard. This is other side. It's actually the same point that hit it. Here you are change the rotation angle of this truck. And then we are going to deal with this interference path. At the same time, you can change the amount of rotation because our cutting hand is not different. However, the words in the video just show the cutting hand of one type. If your cutting hand here can rotate multi-axis, you can change it. A direction of rotation of the cutting hand so that the cutting hand will rotate. I have to go back and look at this. This is the inclination of the cutting hand. We can see that you input different values, the slant of the cutting hand. It's different. This place is slate of the cutting hand. This is the angle of rotation of the trunk. It's not the same thing, but this is where we can see it. Insert the vector of the path, it can insert the inclination and the angle, or you just insert trunk. This is one way to detect it this way. It will be more accurate than if we were to visually see if there was interference. Okay, so that's what collision detection does. Test for interference between the machine contour and the cutting hand. And the way that you can modulate this interference, let's see, we just talked about it. We can modulate this place. The value of this place gives an advanced rotation, and how much rotation can be set here. To avoid interference, the size of the cutting arc region can be adjusted to solve the problem of interference. Also, the values detected in collision detection can be adjusted to be positive. Cut a contour where it enters, and then the next one we look at the open face. Open end, which is also based on the type of pipe. This is angle steel. Let's look at eye steel. This is eye steel. Is sometimes. For some of our pipes, if the shape is very irregular, it cannot generate the two paths automatically. This cut line, then we can do it this way. add a cutting path to it from the end face. This is the shade of I-band, and it will have 3 properties. If I click on the first edge, it will now have a path. If you look at that and then the second side, select. The middle web is selected, so this is the end face. The path has been created. It also has other functions like angle bars. And so on and so forth. You pick the 2 sides of the corner cylinder, and then we can see these 2 places, these 2 edge settings, and then it will generate the outline of this knife path. That's all there is to TTN operations.